basics first. Can't do the hard problems without the basics. So the vector v is between this point and this point. So the implication is this is the tail and this is the tip. So if we want to write that in component form, what is component form of the vector v? So just in general, it's how much x changes and how much y changes from the tail to the tip, right? Because we said that vectors are mobile, right? You have a direction and a magnitude, but the location can be anywhere, and it can maintain the same. It can be the same vector. So, but what stays the same then is how much x changes and how much y changes. So, how much does x change here? So, how do we calculate the change in a variable or a quantity? Final minus initial, right? So if it goes from, and you think about a number line, right? If you're negative 4.8, how much does it change to get to 3.9? Okay, so 3.9 minus negative 4.8, or 3.9 plus 4.8. And then how much does y change? It starts at, think of a number line, starts at 2, ends up negative 4.4. That's a negative change, right? Of 6.4. Okay? So let's just do that and get the value here. So that's 8.7, 6.4. So how do we get the length of v? So this is important. Yeah, we think about that these components form a triangle with the magnitude of the vector. And the length of the vector v is the same as its magnitude. Okay, so since vectors are mobile, let's just go ahead and put its tail at the origin. So if we put its tail at the origin, it's going to be 8.7, 6.4, something like this. Negative. One more try. So 8.7, negative 6.4, like this. So the x component is 8.7, and we can think of the actual vector as the sum of two other vectors, an entirely horizontal vector and an entirely vertical vector. So this is like 8.7 comma 0. That's the x component vector, and then 0 comma negative 6.4. If we were to add those together, we would get our vector, right? Our vector v. So that magnitude, which is a right triangle, right? It's going to be a right triangle. So we're going to do square root of 8.7 squared plus 6.4 squared. Uh, 8.7 squared plus 6.4 squared. Okay, so now if the tail of v is at negative 1.5, negative 1.6, then the tip is at. So we just got to think through this. This is easy. It's as long as we understand what the vector represents. So negative 1.5, negative 1.6 is the point where we're going to put the tail. All right, and then what it's going to be, then from there it's going to be over 8.4, 8.7, and down 6.4. So then the question is, what are the coordinates of that tip point? So we start at negative 1.5, and what's our change in x? So how are we going to get the x coordinate of the tip? Just add it, right? We're just going to add it. We're just saying negative 1.5, and a change of 8.7 is going to put us at. Now this is a point. This isn't a vector. This is a point. So we use parentheses. So negative 1.5, and we're going to add the change, 8.7. Start at that point, make a change of 8.7, you're going to get your final point. So final equals initial plus the change. We saw that, in fact, we saw that when we were doing constant rate of change. And then initial y value is negative 1.6. How much does it change? Changes by negative 6.4. So it's from negative 1.6, it's going to go down 6.4. Okay, and so then similarly, if the tip is at 1.9 and it's at 2.3, then where's its tail? So the tip's at 1.9, and we know this vector has a change of 8.7. So what are we going to do? So we're at 1.9, and it's like we're going back to the tail, right? Back. So it'd be 1.9, what? Minus 8.7. Right? So these components of vectors, the key is that there are changes in x and changes in y. So if you're at 1.9, then you go back 8.7, you'll be at your starting point, right? And then same with 2.3 minus negative 6.4. Okay, so what vector has the same length of v but points in the opposite direction? So I'll do that red, like this. So here it is. Same length, points in the exact opposite direction. What will the x coordinate be, or x component? Negative 8.7. And what will the y component be? Positive 6.4, right? So if it goes in the exact opposite direction, then your components are just going to be the opposite. So this will be negative 8.7 and positive 6.4. This is a vector now, so we need the chevrons. Okay. What vector has the same direction in v but is twice as long? So if it's twice as long, what about the x component? Twice as long. What about the y component? Twice as long. So there's two ways to express this. You can do, this is called scalar multiplication. You can multiply a vector by a scalar, meaning just a number. So it would look like this. Okay, so that is the same vector as v but twice as long. Or you can, so then what does that mean? That means that the x component is twice as long and the y component is twice as long. So we could also express this as, what's 2 times 8.7? Is that 17.4? And then negative 12.8. So both are valid ways. I wrote both of them there. So you can write it this way. 2 times the vector 8.7 minus 6.4, which means, let's just do equals, 2 times the x component, 2 times the y component. Okay, really important basics. Does anybody have a question? There was lower success on this one, so hopefully that helped. Anybody have a question? Okay. Look at another one here. Let's do the last two. Okay, given a velocity vector blowing 20 kilometers per hour towards the northwest, what's the vector and its components? So we have all the information we need for a vector, because what is a vector? A vector has direction and magnitude, and that's exactly what they gave us. What's the magnitude of the velocity? What's the magnitude of the velocity? 20. Okay, remember we talked about velocity is a vector, and what's the scalar magnitude of velocity called? You got to know this. You got to know this. Speed, okay? Speed is just how fast, right? And so what it ends up being is, it ends up being the magnitude of the velocity vector. Take the speed and add with it, or combine with it direction, and you've got a velocity vector. So speed is just the number part, just the magnitude, how fast. Velocity is vector, speed and direction, speed and direction. So 20 toward the northwest. And so how can we express northwest? So this is 20. The length of the vector is 20. And how can we express northwest, say, in polar form? .45 degrees, what? North of west. 45 degrees north of west is the direction northwest, exactly halfway between north and west. Okay? So now they want us to write vector v, and what they're saying is in component form. So we've got a x component, and what do we know about the x component right off the bat? Negative, right? The x component will be negative, and the y component will be positive. And how do we get those magnitudes, right? So how do we get, so this is our x component of v and our y component of v. How do I get that length right there? If that 20, yeah, so remember the cosine of 45 would be like in radius lengths. If our radius is 20 and we want it in kilometers per hour, then we're going to take 20 times that, right? So it's 20 cos 45. But we know it should be negative. So another alternate thing you could do here is you could do positive 20 times 135, because cosine 135 will automatically give us the negative that we want, right? Because 135 knows that it's in the second quadrant. But if you use 45, then you need to include the negative because cosine 45 is positive. Does that make sense? All right, so we got negative. Let's use negative 20 cosine. Now, so there has to be a type of angle measure that WebWork uses. If you're going to put in cosine or put in sine, then you can't just choose whatever you want for the angle measure. There has to be like a default or a standard, and that is radians. Okay, so if it's 45 degrees, how many radians is that? 5/4. So if you put in 45, it's going to think you mean radians, because if you're using the cosine and sine functions in WebWork, it can't read your mind. It can't know that you want degrees when you put 45 in, and then pi when radians when you put pi in. So it's always radians. And then the y coordinate, 20 sine pi/4, and that's positive because it's going up. So that would be our components. And we know what those are, right? That's radical 2/2. So another way we could do this is, if we wanted to, we'd say negative 20 radical 2/2 and 20 radical 2/2. So what, negative 10 radical 2 and 10 radical 2. Yes, sir?
All right, so when they don't actually give us an angle measure, then we always assume that's a 45 degree for the direction. Because when I was looking at the problem and it just gave me the 20 kilometers an hour in the northwest, when we were practicing class, it was with an angle measure. So
but northwest is exactly halfway between north and west. So you don't call northwest just any direction this way. That's a precise direction.
Okay.
Yeah. So yeah, I mean it's a little ambiguous, but without any more information, you just have to assume that northwest is exactly halfway between north and west, southeast exactly halfway between south and east, etc.
For the test, are you going to be looking for this in radians or degrees?
You should be able to do both. You should be able to do both. But remember, if you want to relate it to arc length, you need radians. You got to have radians. What's the problem?
This is making fun of me.
Okay.
It's like slammed.
No, yes, you got to do both, and then if there's ambiguity in the question, then come ask for clarity. Just come ask me. But I've tried to make the questions as clear as possible that there wouldn't be any question. Okay. All right. Other questions about this one? Okay, last one. Okay, so important question here. So we have a boat heading due east, and the current is moving southwest. So let's say that the current's moving southwest. And maybe it's like a southwest. No, that's not too bad. Yeah. So current usually just is exactly. So we have our river here, and the current is southwest at 12 kilometers per hour. Okay? And then the boat is heading due east at 20 kilometers per hour. Okay, so I'll make that shorter. Start over. There's 12. This is the 12 kilometers per hour. That's what the current's doing. And then the boat is heading due east at 20. It's the best vector I've drawn all day. Okay. So the actual movement of the boat, what they're talking about is relative to the ground. Relative to the ground. So the water has a pull on the boat, 12 kilometers to the southwest, and then the motor of the boat is saying, I want to go 20 kilometers per hour east. Okay? So then what's the result? So the result is, it's what you would get if you added those two together, right? So it's what you would get if you added those two vectors together. There's the two influences on the boat, the water's influence on the boat, and the motors and the steering's influence on the boat. So you add those together to get the resultant direction and speed of the boat. So basically, the red one here. So we're gonna put. I'll just take this one here, and we put it tail to tip, like that. I should have made that black because it's still the same vector as the black one. This is our heading of the boat, like this. So then the resultant vector is something like that. That's how the boat is actually going to go down the river, right? So it's mostly going to the east, but then as it goes to the east, it's going to get pulled to the southwest by the current. Okay, so how do we add vectors? What do we need to add vectors? Polar representation or component representation? Right, so we said with adding vectors, you're going to need component representation, so you can add your x components, add your y components. Okay, so this is, say, we'll call this vector B or H for heading. What's the components of vector H? Now, this is speed, not displacement. So you got to think about this as occurring kind of in a moment of time. In a moment of time, the speed is 20 kilometers per hour this way, and the current is 12 kilometers per hour that way. So it's not that the boat starts here and ends here, or starts here and ends here. It's that when you do velocity vectors, you're capturing a moment in time. All right, and the length of the vectors is just that current speed. It's not a displacement. It's not a movement. Okay, so what are the components of H, and what are the components of? We'll call that the current. C, current vector. We got the current vector and the heading vector. If we can get those in component form, then getting the sum total of those is a piece of cake because you just add the x components and add the y components. So heading vector. What are the components of the heading vector? 0, 20. 20, 0. Which is it? 20, 0. Right? It's that the speed is entirely in the horizontal direction to the right and not up and down at all. Okay? How about our current vector? So our current vector is, how about the x component?
Negative.
It's going to be negative.
12 cosine.
Negative 12 cosine. Yeah, and if we can express it, we're just expressing it, we can express it as degrees if we want, just knowing that if we put it into web work, we're going to have to put in the radian equivalent, okay? But we can express it as degrees. And then the y coordinate?
Negative 12 sine.
Okay, because this is what? This is 45 degrees south of west. 45 degrees south of west. And so, but we know what cosine and sine of 45, they're both, it's radical 2 over 2. So this is going to be negative 6 radical 2, negative 6 radical 2. Right? 12 radical 2 over 2 is 6 radical 2. So we got the current vector and we got the heading vector. And so what's the actual movement of the boat? Or what's the velocity of the boat relative to the land? Relative to the land would be 20 minus 6 square root of 2. And then minus 6 square root of 2. So that would be our actual vector movement of the boat. And so let's just let's get the numbers here. 11.515, negative 8.5. Okay, how fast is the boat moving relative to the ground? So we've got the vector representing its motion relative to the land. What about how fast? What is how fast? What is that? That's the speed, and that's the magnitude of the velocity vector. Really important. The speed, or just the number, how fast it's going, regardless of direction, then will be the magnitude of your velocity vector. And so we know how to get that. We're going to do that squared plus that squared square root. Okay. So do you think it's going to be faster or slower than 20 kilometers per hour? Why slower? Yeah, the current has the component of the current in the x direction is in the opposite direction. So it's actually there's some cancellation effect there, right? Because that 20 is offset by the fact that the current is pushing in the other direction. The x component is in the opposite direction of the 20, so we expect that to be less than 20. Okay. All right. Now, important. What angle does the current push the boat off of its due east course? Your angle should be a positive angle less than pi radians. So what they're asking for is the positive angle, what, south of east. They're asking what positive angle south of east. What angle measure south of east, because that's how it's pushing. It's pushing it off to the south of east, right? How are we going to get that? So we take that red vector. Got that red vector. That's the actual movement of the boat. And we know its components, so we make a right triangle, right? We make a right triangle out of its components. And so this is the 20 minus 6 square root of 2. And then the minus 6 square root of 2. How can we get the angle theta? Take your pick, because in number 2 we figured out what this was. This is the speed, right? So you've got all three sides of your triangle. You've got your x component, 20 minus 6 radical 2. You've got your y component, 6 radical 2. And you got your speed. That's the length of the hypotenuse. Right? Your speed is the magnitude of the velocity vector, so it's the length of that. So take your pick. You can use cosine, tangent, or sine. So since we don't have the speed right in front of us, we have the opposite and the adjacent side. Let's use tangent. So tangent theta. And now it's going to equal negative 6 radical 2 over 20 minus 6 radical 2. Okay, but like inverse sine, inverse tangent gives you an angle between negative pi over 2 and pi over 2. So remember, inverse cosine gives you an angle between 0 and pi. Inverse sine gives you negative pi over 2 to pi over 2. And so does tangent. So does arctangent. So this negative here will give us this negative angle. So let's do this. So go to your calculator. Get your calculator. And let's see this happening here. So if y is negative and x is positive, that's going to be a fourth quadrant clockwise angle, right? So do the arctangent of this expression. Make sure you're set. So set your calculator to degrees. Set your calculator to degrees first, so that we get a degrees answer. And then do once it's in degrees, do arctangent of this expression right here, negative 6 radical 2 over 20 minus 6 radical 2. And we're expecting a clockwise angle into the fourth quadrant, or a negative angle. And as soon as you get it, tell me what it is. Negative 36.38. Does somebody else get that? So it's negative because you entered in a negative y component, as the opposite side you had it as negative. So that means that's that clockwise angle into the fourth quadrant. So they want, what do they say? They say your answer should be a positive angle less than pi radians. Okay? So now I guess they want radians. Okay, so usually they want degrees in these problems, but they want radians. So we'd have to go back, change your calculator to radians, and do it again. But if we're talking about what's the angle measure south of east, that's going to be positive, right? That's just going to be how much south of east are you as a positive angle, not related to the unit circle anymore, okay? Not related to the unit circle, it's just what is this amount of openness south of east? Anyone got it in radians? 0.635. Okay. Does all that make sense? So I talked a lot about different stuff there. But the key is that you're finding this angle, you're using your triangle, and when we talk about the polar form of a vector and we're expressing the direction with south and east and west, it's always going to be a positive angle. So you're always going to be positive. Like in this case, the positive sweep south of east. Because once we get into these applications, we're not really talking about the unit circle anymore, and clockwise is negative and counterclockwise is positive. The south of east language will always have a positive angle. Make sure that's right. Good, we got it. We know how fast is just the magnitude of that vector. It's the square root of the sum of the squares of the components. Okay, other questions on web work? Okay, so you have all the tools to do these types of problems. They can come in different forms, right? So what they give you and what they're asking for, there's like a dozen different kind of configurations of that. But what we've talked about is you have all the tools to solve any of these types of problems. So let's look at just another example. Spare room down here. So suppose you have a box, you're looking down on the box. And someone comes along and pushes it with 40 pounds of force. And that's say 32 degrees below horizontal. So it's not really south and north and stuff. But in this picture below horizontal. So you're looking down on the box, and someone comes along and pushes with 40 pounds of force that way. And then someone else comes along and pushes let's say they're trying to work together here. So someone else comes and pushes with 55 pounds of force. And that's at 79 degrees below horizontal. So ignoring friction of the box, this is the top of the box. So ignoring friction, how many pounds of force are applied to the box, and in what direction? So ignoring friction of the ground. Well, that doesn't matter if we're just asking about the pounds. Okay, so I'm going to take attendance. You got your task here. So you got all. So what's our approach to doing this problem? It's all about what? Total amount of force is obviously 95 pounds, right? No, there's direction involved, right? You can't just add 55 and 40 because they're in different directions. How do we take care of that? How can we figure out the sum total of the force applied to this box?
Figuring out the components.
Components, right? We got to get the components of each one. Component form allows us then to combine them because we can add apples to apples, right? Change in X to change in X, and oranges to oranges, change in Y to change in Y. But you can't, it's not 95 pounds because they're in different directions. There's different directions, so it's not 95 sum total pounds applied to the box. Okay, so components, so we'll call this, I don't know, V1 and V2. Components for V1. So we're going to write V1. What will it be? Let's see, do we get the components for V1?
Negative 55 cosine of 79, negative 55 sine of 79.
Negative because to the left. Cosine because it's x coordinate. And then?
Negative 55 sine of 79.
All right, somebody new. V2. So V2 is this vector over here. So what will that be? Elijah, you want to do it? So what if we want the kind of the resolution of all the force on this box, what are we doing? Adding, right? So it's going to be this plus this equals, it's going to be a vector like this. Right? So V1 to show vectors being added, you have to put them tip to tail, right? First V1, then from there V2, and then so then the result is what the single vector that would be from start to finish. So I'll just call it V. Okay, so V then is going to be we're just going to add the x components and add the y components. So does anybody have those? So when you add these two together, anyone got a decimal approximation for that?
Negative 44.416.
Go with that. Negative 44. Does someone else get that?
Yeah.
Good. All right. So that's the sum total of your x component. Your x component of V1 plus your x component of V2 is the x component of the sum. All right. And what about adding the y components? 70 what? Okay, so now we have component version, and now I want to switch that back to polar version so we know exactly how many total pounds are being applied and in what direction. So we know to get the magnitude of that, we're going to do the what? Square root of the sum of the squares. So we represent that this way. So you could do it with one set of bars or two set of bars for vectors. They both mean the same thing. It both means the magnitude. And this would just be the number of pounds regardless of direction. And it should be a little less than 95 because 95 would be if they were in exactly the same direction. But as soon as their directions are off a little bit, you're not getting the full sum of 55 and 40. So do we get 90 or 85 or what do we get? Anyone got it? Nice and loud.
87.33.
Someone else get that?
Yeah.
So the resolution of these two forces on the box is a total force of 87.33 pounds. And then if we want to get direction, we can use tangent again, inverse tangent. So tangent of theta equals, and we just do 75.19. Opposite over adjacent. Theta equals arctangent of that ratio. Anybody got it? Make sure your calculator's set to degrees. We're going to get our answer in degrees. Does someone else get that? 59.43 degrees, which makes sense because that it's going to be in between, right? The angle that we're pushing at is going to be like in between the 32 and the 79, somewhere in between the two, and that's what we got, 59.43. Again, below horizontal. Or what's south of, if it was using north, south, east, and west, it'd be south of west. Okay, so we'll have one more web work that's more practice of this stuff. It's important for the final. And then let me show you here. Let's do an example. So you remember that your final is Tuesday night at 7 p.m., LSA 191. Okay, I will have like just an open study session. Let's write this down in here. Open study session, office hours. I won't have anything prepared. You can bring your questions. So study session, Monday, noon to 2 in ECA 225. Okay, don't walk up and don't walk away yet. There's other important information. Okay. In exam prep, shortly, this isn't there yet, but shortly in exam prep, you'll see final exam study tips. Okay? And here's what I'm suggesting to get ready for the final. I put a list of practice problems. So this is it'll look just like this. This is right where you're looking at for another class. Okay, so I'll put this up in the next hour. But there's a list of practice problems from the workbook, homework problems. Lots of them are odds, and you can get the answers to the odds online at the rationalreasoning.net. And then besides those, all the web work that relates to those problems that I picked from the book, any web work problem that's similar to those is great practice, and all those are still available. And then your hour exams, if you want to review your hour exams. Now we know that it's Monday from 12 to 2. Monday from 12 to 2 would be a chance to look over your hour exams, or possibly today if you talk to me, so that I have a little bit of time today. Okay? So study, get your questions answered, and then I will see you. So that will be in exam prep, and then all the information about the final and the review session is on announcements right there.